This is Mario with Mia Microflight once again, and on this video we have a slow stick. This is one of the more modern slow sticks. This wing belongs to a customer of mine who actually bought the later version of the Mia trikes that I'm doing for the Quicksilver Ultralights, and so he gave me all the parts. He gave me the wing. He actually assembled the wing and gave me the stabilizers and some other stuff that he gave me, servos, electronics. He flies typically in one of the original Mia Microflight trikes for the converted to an ultralight with the GWS wings as an FPV setup. Him and I were talking about it. He decided to buy another one and to beef it up, so this is what I have done in this particular version here. It's a lot beefier than the original trike that I started doing for the slow sticks, considering that, you know, he has a lot of gear in his FPV setup, and he's flying with this motor right here. It's about 600 watts. Typically I fly mine with a 400 watt motor, and it's plenty for what I do. But like I said, he flies FPV and he's trying to go long range. He's getting about 40-minute flights, and with that setup and in a very large propeller, 13 by 6 I believe. But he wanted me to put this together for him, and he gave me all the parts, so that's what I've been doing here. Like I said, it's a little bit different than the than the typical or the original trike that I was doing. The original trike is not triangulated so much as this particular frame is, and I had to do that just to provide additional reinforcements at the points where it is bound to bend if you land hard. Now, the original design was meant, you know, to do a lightweight ultralight, and so it wasn't meant to carry a lot of weight, you know, with a lot of FPV gear and very heavy batteries. So that's why I made it lightweight. And you know, he took that to a very higher level, and so you know, he crashed a couple times and bent the frame. So what I did is I took that information, and as well as my own flights with my own GWS converted ultralight, the Mia trike, and I really flew the hell out of that setup until I broke mine. And I decided, well, you know, if we are going to be flying this a little bit heavier and with a lot more gear into it, you know, the frame needs to be beefed up. And so this triangulation that you see here is what the new frame encompasses. And I mean, I took this thing and I tried to squeeze it, see if I could bend it or deform it, and it was very hard because of that. Everything's triangulated and it's bolted. So there's no gluing whatsoever here, and there's no gluing whatsoever in the Mia Microflight ultralights. So this is the new frame, and I'm sorry that my table's a mess, but you know, this is how I work. I mean, I work like a painter, paints, you know, with a lot of colors on his palette, and so I need all these tools and everything in front of me. But you know, eventually this gets cleaned up, you know, for my next project. The pilot right here is the Cyclops setup that I offered, you know, a few years ago. I was offering the setup here, which has got the pan and tilt camera, and you can see that in some other earlier videos that I did. Basically, it's the same setup. I've simplified the bracket for the pan and tilt a little bit further, and now he can put the helmet, you know, for the Cyclops right over the camera lens. He's got a 600 milliwatt transmitter with this setup here, and I believe that's also 600 or 700 line camera. It's a very nice camera. It's very nice and sharp and crisp, you know, when you're watching this through the goggles. So that's going to be doing the pan and tilt here. Let's see some of the other things. I did not use the original GWS, you know, this rudder vertical stabilizer. I did not use this because this particular model is a pusher, and because it's a pusher, I had to do something different on tail end here. This distance from here to here is is a lot shorter than when you have the motor at the front. Like the typical GWS has the motor at the front and the battery on the stick itself. So you know, when I designed this, the original trikes, the whole idea was to put the battery at the bottom here. So this is where the battery is going to go. I don't have the box. There's going to be a box here, a poly box that's going to hold the battery in place, and it's going to serve as a protector as well. I don't have that set up here yet, but it is on my other one, my prototype, right there. And as I was saying, the tail section is my own. That's my own rudder, and with my own bracing. And this is something also new that I'm doing here. I'm doing this setup here with the servos right on the horizontal stabilizer, and that is to provide short, direct, and more precise control of the rudder as well as the elevator. They're both, you know, facing each other in mirror image, so to provide even control on the and more precise, on, like I said, on the control surfaces. The wires for the servos just run along these side carbon rods. They're solid rods that support the tail. There's no reason to support this with triangulation at the rear, as I was originally going to do, but there's no need to do that, because these rods, they also run the full width of the wing, you know, and attach very, very securely here at the leading and at the trailing edges, you know, hold the wing very secure. He wasn't flying with the ailerons on his original slow stick ultralight conversion, but I kind of talked him into doing that, so he gets a little more precise control. So that's what the setup is here. And once again, you know, short rods to the servos for precise control, and these control horns are sitting at almost midpoint of the actual ailerons. These actually also work as flaps, so it's actually flaperons. That's what you're seeing here. On my original one, I had the control over here on this end here, but I decided to put it here. It would have been ideal to put it at the center here, but this has a hinge clip here. These are the Miyama Flight hinges, so I put it right there, which is just fine, and it keeps the servo a little bit more in line towards the center of the wing. Because one thing to keep in mind is that you don't want to put heavy items near the tips of the wings, because it becomes now the wing starts getting heavy at the tips, and it starts wanting to have, you know, to fight the control. I mean, this one, all the weight is at the center and at the bottom of the frame. You know, when it encounters a gust of wind, or when it becomes a little bit unstable through control, you know, you just let go of the control and it self-stabilizes, because it does have dihedral as well. But you don't want excessive weight at the very tips of the wings or beyond, you know, a certain point. So that's the reason for the servo link being more close to the center of the wing. And so the rest of the gear that he gave me is kind of sitting right in this box here. And I mean, he's got a very nice setup here. He's got the electronic speed control there. We see he's got an Emergent RC 600 watt audio video transmitter. He's got GPS. He's got the Dragon Link receiver, which is a 12-channel receiver. So this unit here. It's just pretty, you know, it's a pretty hefty receiver. Almost reminds me of the Futaba old receivers that I used to use back in the 80s, 70s. I redid this antenna for him. You know, this is the antenna that belongs to the Dragon Link. This is a UHF antenna. And I did this basically just using core flute sections here. I stuck the antenna right inside the core flute. So this is the dipole. It's nice and I mean, it's still flexible, but it's a little bit more stiffer there, that you can mount this on the. I plan on mounting that on the wing. And it's also the same color as the wing, so it's going to look really nice. Let's see if we can activate this pilot here. Okay, there we go. There's the antenna there. The antenna, I mean the camera. So it's looking up and down. Now this helmet right here is just a helmet. It's part of the Cyclops Setup, the Mia Cyclops Setup. So it's not really fixed yet, and this is what I'm working on. I'm working on finishing that for him. But you know, you can see how it moves. Let me just center this focus point here. You know, so basically pan up, pan down, left or right, left, And you have a really nice, kind of cool setup here with the helmet. Now the helmet's not decorated yet, but you know, we can go that far and decorate that a little bit better. I'm going to take it out and do some video and photo shoots on this model, because it's hard to tell here what's going on with all this stuff that I have on the table. Okay, so basically this is the new Mia Microflight aluminum anodized in blue trike for for basically any conversion using any slow stick wing and tail stabilizers. Now this particular one is done in a pusher style, and thus the wing to the stabilizer is a short distance. This one has a tail guard where it rests when the model is not powered, but once it gets powered, you know, it tends to straighten itself into the three wheels, and then it takes off like a regular airplane. But this particular frame is for a customer of mine that has bought a previous one of the original trikes that I did for the conversion of the slow stick, and he's been flying his slow stick FPV. But over time he's been improving the FPV setup, and he's gone with heavier and better equipment. And lately he's got a really powerful motor there. Typically the slow stick is flown with a 400 watt motor, and he's gone with a 600 watt motor, which adds quite a bit of weight, but also adds quite a bit of thrust. And he's using a 13x6 propeller, so it's a huge propeller, and he's getting quite a long time flight here. He asked me to do this particular trike for him, almost as a customized trike with a more robust trike. And so what I did is I took the original design and broke some of the longer pieces in half and started triangulating the connection so that it provides a more solid frame structure in case he lands hard or happens to crash. So that's what this particular frame is about, and I did it in a pusher style because I wanted to keep the front section of the aircraft clean for FPV. You know, I don't want the propeller prop wash to come on the screen, and so that's why this is done. It's also to provide protection for the propeller and keep the model a lot cleaner. Let me move up here. The tail section, I did not use the original. This is a GWS wing and stabilizer, but I did not use the original stabilizer of the GWS because, number one, it's got a funky round section here that sticks out here, and if I would have started at the point where at the base, you know, it would have stuck a little too far into the propeller. So I want to keep this clean. So instead of modifying that, I ended up doing this out of this is just Depron, same material that this is done in, except that, you know, when they do this at the factory, they mold this with a coat of paint on the molds, and so that's how the Depron comes out, you know, with the paint on it. But it's done in white. It's reinforced with it's got triangulation here on the end here, and that's to provide stability for the vertical stabilizer and also to provide stability on the horizontal stabilizer. Now this particular customer of mine went ahead and built the wing himself, so he gave me the wing pre-built. So he had already reinforced this with the typical, I think these are fiberglass rods, these white rods that come with the GWS Slow Stick. It's got at the leading edge and at the trailing edge. But I went ahead and added some more carbon reinforcements here to provide this connection here, reinforcement for this connection. I've also, because he's using ailerons, I also added these diagonals here to provide additional bracing here of the foam, so it doesn't tear from use and abuse of the ailerons or flaperons. Same thing on the other side, mirror image. The servos are already connected, and I've also gone with these strips here of this is core fluid material, and I've also stuck that over the servos with double-sided tape to reinforce that and keep that servo from moving. That servo is not going anywhere, and it's already connected to the control horn. This particular customer also, he added this carbon rod here at the front, so I didn't have to do that. And he also added a carbon rod here to reinforce the tail section. I mean, he's got some savvy already. I mean, he's a seasoned pilot, but he gave me basically all the components, and basically what I did is I redesigned the frame for his use and application. You know, he flies FPV, and there's a lot more wires that are going to be installed here, so I have to clean that up for him and finish that setup here. What you're looking here is the bottom of the pilot torso. This is the Cyclops MIA Cyclops torso section that houses the pan and tilt servos there. So that's what you're looking. The servo here is for the steering. Let me turn this over here. And what I've also done on this particular trike is I've added a full length of aluminum root tube here. The root tube is holding the frame, as opposed to before we were supplying a piece of wood that would attach to the carbon square tube that the GWS slow sticks come with. So that's gone. There's no more pieces here. This is a full piece, aluminum, solid, and it looks nicer too. It's very, very similar to in fact, it's the same tube that I use for the full kits that we do for the Quicksilver Ultralights and pretty much all the Ultralights that we do. So it's the same thing that we're using here, and I decided to add this to this particular conversion just to give it a little more rigidity and more, you know, and more area to attach things such as what you're looking at here now. Particular motor bracket, he gave me the motor with the bracket. I don't know where he got that bracket, but unfortunately I wasn't able to stick that bracket. That bracket is a socket machine aluminum. I mean, it goes over my boom here, but it's a little bit loose. Even with a bolt, I would have had to shim it, and I didn't want to shim it. I didn't want to put little pieces to shim it, so I stuck it at the bottom, and it's solid the way it is. It also brought the motor more in line with the horizontal stabilizer. This rod right here, this tail is the basically just a leg to prevent the model from, you know, fully going all the way to the back, and protects the propeller as well. It's got the Mia Cyclops pilot, and let me just take this out of here just so we can see the camera. Now that's his camera, but those are my parts right here. The aluminum mount is mine. That's the aluminum mount is Mia Microflight, and that's the pan and tilt. Very simple mount system there. And the camera is basically just attached with double-sided heavy-duty tape, you know, to the back of the servo. The back of the servo has a plate extension and that was to raise the camera so that I can fit the helmet, pilot helmet. You know, it's got the hole right over the camera, and this whole assembly can pivot up and down without any restrictions to the plastic molded parts. This is just the torso, you know, just to give it the idea of the pilot torso there. Basically, we can appreciate the frame right here in this particular video segment. You know, you can see all the additional triangulation that I did on, you know, on this particular frame, and that was because when you land hard, you know, excessive force tends to travel to the back of these tubes, and typically that tube would bend. This was a one piece before, so it would bend there, and that tube would also bend, and this was also one piece right here, this diagonal. So now you have not only triangulation, but you have these additional angles here that provide a solid frame. This is a very, very solid frame. You know, given that, you know, when depending also on how hard you crash, I mean, nothing is totally indestructible. But I certainly have provided, I would say, you know, another 100% additional in robustness of the original design. So this frame is designed for, you know, for a solid FPV series application, as this particular customer is employing in this particular model that I'm building for him. It's got the same steering mechanism as the original one. The servo, I installed that closer also to the front end, just to provide just a shorter link here. Although this link is wired too, it is flexible so that it provides good directional control. But at the same time, if he were to crash or land hard, this would bend as well, and minimize damage to the servo. That's the reason why these links, I mean, I like to keep these links a little bit lighter. I don't like to go too robust on these links, because if you put a really stiff link here, if you happen to crash this, and that's going to take the servo and it's going to ruin the servo. So at least you minimize the risk here with these type of links. The struts on this particular one had been extended outward towards, on the original conversion kits, the strut was 14 inches and it would stand up to this point right here of the wing. So I left this section here kind of not attached to anything, because this is an FPV application, like I said, and he flies really hard and hard. I mean, and sometimes he really puts this model through the paces. And just to provide additional stability, I've gone all the way to the ends here of the wing, just to provide solid support. So this wing is not flexing in any form, whatsoever with this particular configuration, with the rods going all the way to the end. Also, the end right here on the tips have been reinforced with carbon, and this is with the Mia Microflight clips that we, consistently use throughout our products, in particular the microlights and ultralight conversion kits. So that's what we're seeing here. Let's take a look at the rear section here of the rear section. I did this. I mean, I don't like to expose servos over surfaces of wings or even horizontal stabilizers. But in this particular case, there was no other way to do this cleanly. So I decided to create some pockets there and reinforce that with fiberglass, some plates. So this is well reinforced here. It's a pocket for each servo, for the aileron, or for rather the rudder and the elevator, and both of them are in mirror image to the rear of the control horns. The wires from each servo run through these rods here that are that provide support at these 2 points for the horizontal stabilizer, and also are attached at these 2 points, at the front and the rear of the wing, through these clips. So this is a very solid connection here. It's not going anywhere. The distance from here to here originally had 12-inch distance, or 6 inches from the center to each side. So I increased this to 14 inches to provide additional gap for his larger prop. He's flying with a 13.6 prop, and you can probably go with even a 14-inch prop, but I would just keep it 13, just to have enough room here. You don't want to get too close to these areas here. The height also can also take a 14-inch prop, but he's got a 13 and he's got plenty of room there for clearance. And even with this flexing there, he's not going to hit the ground. So once again, this is the GWS, another conversion. This is the latest conversion. This is July. We are in August, actually, 2016, and this is the latest and greatest. I'm calling this the Ultralight, the ultimate FPV Ultralight conversion kit for the GWS. It's very robust, and it's designed specifically if you have FPV gear that you want to install, and you're not too much worried about weight here. This model with all the FPV gear and in a hefty 5,000 milliamp hour battery, it's coming out at around 3.5 to 3.75 pounds. The wing loading on this is about 14 ounces to 16 ounces per square foot. So it's still within a good handling capability. But of course, it's not designed for beginners, because this is an FPV, and the person that flies this, customer of mine, is he's someone who I would consider a professional FPV pilot, or a seasoned FPV pilot. He's not a beginner. So this is a trike built for that purpose. Once again, this is Mario with Mia Microflight, and don't forget to subscribe to my YouTube channel, and also visit our website. If you like what you're seeing here, don't hesitate to email me with questions, If you want to buy one of these, also look at the Mia Quicksilver Ultralight, and we have some other ultralights that I'm producing, and I'm trying to show videos and product photos as well on my Facebook page. Thanks for watching.